check, green check, green check, light, green light. Green means go. All right, here we go. Thank you. So, waterfalls. So, success criteria. Here's what you need to know. Please make sure that you have these down. That way you can go back and check off. I know how to do this, I know how to do this, I know how to do this, I know how to do this. So, we're going to be writing the augmented matrix for a linear system, the augmented matrix. We've done some of these things already, so I don't expect there to be a lot of time doing this. But if you have questions, you can ask them. You're welcome to. We're also going to do the perform matrix operations. You can do these on your calculator, but they're going to be a little bit tougher. I want you to see them, what's really happening in your calculator, what you're doing by hand, so you understand the process and why we're so thankful that we have graphic calculators. If you are going to college, you're definitely going to want to invest in one and get your hands on your personal, because you will use these a lot. I know that I did. I really depended on mine. So, okay. Questions? Then we're going to use that Gaussian method to solve systems. I think I already showed you guys, right? The diagonal multiplication thing, and you subtract them. So it shouldn't take too long to do that, and then we can use that to solve. You know what? This one we probably don't like. We'll see right now. We'll get to that. Okay. And you know what? That's okay. As long as you can solve a system. If you want to convert it back into a regular system and then solve that, then more power to you. Does that make sense? It always just comes down to being able to solve them. And I'll tell you what that means in a little bit, okay? We're good here? What are we starting with here? Oh, so matrices. Matrices are used to display information to solve systems of linear equations. A matrix, if plural, it's pronounced matrix. Matrices. Is a rectangular array. The information arranged in the rows, columns is placed in brackets like so, and each item is called an element. Each element has an address, if you will, its own address. And that's not actual vocabulary, but I like to call it that because then I can refer to one on its own. And of course, it's not going to tell us.
Wait, how
so,
do you do that? Is like, what's the coordinate for that?
Right, so that's the address. So if I'm talking about this guy right here, you're always going to be talking about rows and columns. So that guy right there is row 2, column 1. So that would be R2C1. And so if your matrix is large enough, you might even get R2D2, right? No, I'm just kidding. Because they're only R's and C's, rows and columns. What's the name of this guy? What's the address for him? Row 1, column 2.
But like, how would you write like this square in like a coordinate? So like, how would you put a coordinate in the square?
How would you put a coordinate in the square?
Yeah, like, how do you get the square?
What? I really don't understand your question.
Like your X and Y
Yeah,
coordinates.
like if you had two coordinates, is that where you're getting the square?
No, this is just an example. So we can talk about what a matrix is and what the elements are and their address. But yes, if you were going to do, they're not really, well, because you can use them for geometry for like when you're doing dilations. So they could be your X and your Y's, but they can take on a bunch of different meanings. Okay, so I'm a little hesitant to say your coordinates because matrices are used for many, many things. Okay, they're just ways that we arrange our data. Information, that's all it is. Okay, ladies in the back. Gracious. I have also seen I and J. I could be tripping, but I and J as well for like rows columns. But I'm just going to do R's and C's. Okay. Any questions on here? No, we're good. Okay. So the first step in solving a system is to create what's called the augmented matrix. An augmented matrix has a bar separating the column. So if we were talking about a system, you would have your X's, and then you'd have your Y's, and you'd have a bar that separates them from your answer. So think about the bars like the equals, and then you would have solution 1, solution 2, and these are your This is what's called the augmented matrix. It's not none fancy about it. What's up?
So is it Y2 under Y?
Yeah, it should be Y2. Thank you.
Wait, so what is the S stand for?
Solution. And I'm just making them up. They're not real. They're not real stuff. Okay. They just, you can put A in there if you wanted to for answers. Here, let me show you what I mean. So this system becomes this augmented matrix. This system becomes this augmented matrix. Go ahead, ask your question nice and loud. Why would anybody want to?
Yeah, go on. Yeah, why would anyone even want to do that?
Why would anybody even want to do
How
that?
does that help the augmented matrix?
It really is going to help if you're going to do your calculator work. Okay. As far as row operations, there are other methods that are much easier, if you will, than this. But what this is going to do for us, just so you guys know, it's really going to help you understand how it is that systems work. And you remember how when we were trying to solve systems, how we would always change one to match the other one, so that they would be the opposites, and then we can eliminate those, and then we would have one variable left. Okay, that whole idea. So we're going to be working with that today. Working with this is going to be easier to do those type of row operations than it is going to be easier than to do taking two. Remember how I did that? Take the first two, take the second two, eliminate the same variable from both. That took like I don't want to say it was a whole page, but probably more than that, right? You guys remember that 3x3 system I did? Right? And I was like, that's a lot of time, right? So augmented matrix is going to kind of be the setup for us doing these things called row operations, okay? And it's the same thing that you have been doing already for elimination, so it's not a big deal. Like, oh, yeah, I can do that, okay? Wrong folder. Evan, put that in your backpack, please. Waterfalls. So let me take your attention up to the board. Up here on the first augmented matrix, this is simply all the coefficients and answers for that 3x3. I want you to notice this diagonal here. That is the main diagonal of this augmented matrix. As we start to create this thing called, kind of a solution matrix, we want to do what's called a row echelon. And I think we already talked about RREF before, which is reduced row echelon form. That's too much work. What we're going to try to do today is row echelon. In row echelon, you're going to get this main diagonal to become a diagonal of ones. Okay? And then anything that's under that should just be zeros, like in this bottom one. You see that? So we want to convert this augmented matrix to look like this bottom here. This one here is in what's called row echelon form. Echelon form. Okay? And what's nice about doing row echelon form is that when you get to that point, you pretty much solved everything. You should get one equation, which gives you the last variable, which will be z. You'll take z and you'll plug it into that position to solve it for y. And then you'll take those values of y and z, plug them into the last one, and you're going to get your x.
So are those, is that the same equation as one on top of it?
I'm not going to say yes because I'm not sure, but I think it might be. I suspect it will. But we're going to walk through right now and see if it really is, okay? So, yes, it's going to change everything from here to that eventually to be a reduced row echelon. What's up?
What did you just say, like you get the x?
Yeah, once you're in row echelon form, then solving it becomes a cinch because you have one solution, right? That gives you z. Once you have z, you're going to plug it in there, and you're going to be solving it for y. Once you have y and z, then you're just plugging back into the up one. So you're kind of working your way up at that point, and it's just a matter of substitution. Okay, instead of having to do all the stack them, eliminate one, create a new system, solve that system to get one variable, and then work your way back. Very similar. Okay, so some people like it this method. Some people do not. Say that one more time.
How do you even get it in row echelon?
I know. So in order to get into row echelon form, we're going to have to perform these things called row operations. And it's a pretty simple idea because there's only, I believe, 3 operations that you can perform. There's only 3 operations you can perform. Okay? So if you know how to do those 3, which I'm sure you guys can, you'll be just fine. Okay?
There's only 3 ways you can do it.
That was funny. Okay, so there's that.
I wasn't done.
Oh, sorry. Here?
Yeah. I'm trying to be a better person.
Are you gonna solve it?
You can do it this way. Some of you guys are looking up, down, left, right, sideways, north, northwest, northeast, southwest, southeast, clockwise, counterclockwise.
Waterfalls. Waterfalls. So, I've got my augmented matrix here, and we're going to use our row operations to get to that row echelon form, okay? I don't think we're going to mess with reduced row echelon because, well, we could, but nah, it's too much work, okay? So you guys ready? First operation is that you can swap rows.
Whoa.
You can swap rows, so you can rearrange them any way you want. Does that make sense? So if I wanted this one to be up top, do it. You can swap them in any order you want.
Yeah, with that. Oh,
Okay.
so you could.
Well, remember what we want. If we want this first diagonal to be all ones, well, this already has the one there, doesn't it? Or this one. Why not just kick it to the top and I'm halfway there? Simple enough? So
if you flip the first and the second one, you already have 2 of them done, don't you?
I already have one of them done because what needs to be under that one? Zeros. Okay? All right, so everyone's okay with that? Now, when we were doing elimination,
How does that not change like where the answer is? Do you like if you put it back at
No.
the end?
mm-mm.
But like if it's X, Y, and then like Z, wouldn't that change if you move them around?
No, because you're eventually what you're going to do is you're going to get that diagonal of ones and zeros under that, correct? Once you have that, then you know what Y will be to plug into the other one for. Sorry, you'll know what Z is to get into the X, or sorry, to the Y, and then you get those two to plug into the Z part or the X part.
If
Sorry.
you change it, it'll like fix itself and
Mhm.
stuff.
Yeah, it's just like elimination, right? Why are you multiplying 1 by 2 to get to the opposite of the other one? Doesn't that change the whole equation? No.
Keeps it equal.
So, but if I'm all I'm doing is moving their position, I'm still just chasing that same value. What's up? Yeah, you have to move the whole row. So, what's the first formula? Row swap or swap rows, whatever you want to call it. Swapping rows. What?
It's like a math year term.
What? Row swap?
Yeah. Sounds like a bad dance.
No.
Oh.
Row swap.
He was
Thank you.
hitting it, though.
Waterfalls. Second is that you can multiple. I was trying to get both sides of the audience here, okay?
You have 3 different ways you could be doing it.
Okay. You can take any one of those rows and you can multiply it by some value. Right? How does that change my problem? I can take any one of those equations and I can just multiply it by any value I want. So if I wanted to take this equation and multiply it by 2, I can do that as long as I do it to the whole thing. That's legit, right? We've been doing that since what? Pre-algebra? Whatever you do to one side, you do to. Okay. Don't. So actually, that the rule does specify that multiply by any value you want except for 0 because otherwise now it's just gone and then you can't really do much with it. Okay. So you can multiply any row by any number you want. You good?
Besides 0.
Besides 0. Thank you. Thanks for disclaimer there. Corbin will be my disclaimer notice. That guy that talks really fast at the end. And then the third one is kind of like a.
You do not multiply by 0.
Waterfalls. The third rule is just kind of like a carbon copy of the other one with a little tweak in it.
We didn't do the second one. Oh, that was the multiply. Never mind. Go on.
I think seeing iterations will also be a thing for generation.
8, 1, 3.
Wow. I'm not sure what's going on today. So the third rule is a copy of the second one, in a sense. You can multiply one equation by number. So I can multiply maybe this equation by 2, and all those values that I get, I'm going to add them to another row. Okay? So I can multiply, like if I wanted to multiply this equation by some number, and all those values that it produced, I add them to here. Okay?
Wait, so it creates another row?
No, it doesn't really create another row. You're just modifying one row. Okay?
Which,
So in essence, you're adding to an equation.
Can you do all of them?
yeah.
Well, we're going to work through this one and see what they look like, okay? So, and then we're going to see if this was the other one given to us, okay? So here we go. First thing I'm going to do is I'm going to do a row swap. I'm going to do a row swap. What do you guys want to do?
Bring the third one to the last one. Push the top and the bottom.
You guys want to bring the bottom one to the top?
Yeah, top, bottom.
So I'm going to take row 3, and I'm going to swap it with row 1. Okay? So now I've got 1, 3, 2, 25, 1, 1, 2, 19, 3, 1, 2, 31. Guys, make sure that I write the numbers right because it'd be embarrassing once we get to the end. It's like, who messed that up? So there's one of our operations, right? Just a row swap.
Multiply something by -1.
Well, I already want this to be a 1. Okay? Are we good here?
You just want to get
Hey, can you guys put your pencils down and watch? Because these operations aren't that difficult, and then at the end I can let you copy. But I want you to see what's happening here. Because the operations are very simple. They're just, it's going to take long because I have to explain everything. But as you do this, it really just goes by really fast. I don't want that. I need this to be a 0 now, and I think you offered something up.
Multiply it by -1.
I can multiply by how does that give me a 0 though? That would just make it a negative one, wouldn't it?
But then once you like add something and then
So I can do that last one we were talking about, right? I can multiply a row and add it to another. So I'm going to take row 1, I'm going to multiply it by -1, and I'm going to add those values to row 2. So notice my notation. I'm going to multiply row 1 by -1, and I'm going to add those values to row 2. Do you see that?
Is the one on the top still row 1 or is the one on the top row 3?
No, this is your new row 1.
Okay.
Now this is row 2, this is row 3. So here's the values. When I multiply this by -1, I'm going to get a -1, -3, -2, -25. And I just do that. That's the way that my method, I guess. I don't know if that's like the method, but that's what works for me. So, is my first row changing? No, what's changing?
The second.
The second row. So this is still just 1, 3, 2, and 25. However, row 2 is now 0, -2, 0, -6. Double check my work.
Wait. Negative 6. Wouldn't it be 0?
19 minus 25?
Oh, my bad.
Wait, but that doesn't help.
Yeah.
Well, then
We're not done. So now we have, and then did the last one change?
No, but then you can just plug in the negative 2 to that one.
So now I have 0 there. How can I make this a 0? Now I'm showing you methodology as well. I'm starting with the first column. I'm going to turn that into a 1, 0, 0. And then I'm going to go after the next column. And I'm going to turn this into a 1, then 0. And then finally I'm going to get this to be a 1. So I'm working my way downward here, okay?
Wait, so
When I first started, I was trying to figure out everything as I went. No, I'm showing you the fastest route. Start with 1 here and get zeros under that. Then go to 1 there, zeros, and then 1 there.
wait, so
All right? So let me go back real quick. So I'm going to steal Giuffre's idea. Giuffre, how can I get this to be a zero there? How'd you get a 0 here? What did you multiply? You multiplied row 1 by negative 1, and you added it to row 2. What can we do to row 1? Row 1 can get multiplied by a negative 3, and then we can add those values to row 3.
I just think in the moment, man.
Right?
I don't know.
That was some great thought.
Wait, so you just use row 1?
I am, for now.
You can use row 1?
You can use it as many times as you want.
Can you use row 2 too?
Yeah, but how do I get that to be this?
Yeah, that's what I was wondering.
Yeah, if I multiply anything here, it just ends up being 0 again. So you see why we don't want to use 0 as a multiplier? It just ruins things, the ruiner. So that's my approach there. Everyone cool with that? So the values are going to be negative 3, right? Negative 9, negative 6, and negative 70. Question. Did row 1 change?
No.
So it's still going to be 1, 3, 2, 25. Did row 2 change? No, that's still 0. Negative 2, 0, negative 6. Did row 3 change? What's it become now? No, you guys are rolling with it. Negative 44? Beautiful. Beautiful. Waterfalls. There's a question on the floor. So, row 1 didn't change. Row 2 didn't change. On row 3, we did this to it. We took all of these values, multiplied them by negative 3. Here they are. And then we added them to the third row. So, 3 minus 3 is 0. 1 minus 9 is negative 8. 2 minus 6 is negative 4. 31 minus 75 is negative 44 according to Blue. We're good? Okay. So I've got my first column exactly the way I want it to be, don't I? Now I'm going to go for the second column. Do I care about this 3? Not really. I need this negative 2 to be a 1. This is a simple fix. I'm going to take row 2 and I'm going to multiply it by negative 1/2. That's my second rule, right? I can multiply any row by any number I want, even though I'm cheating because I'm dividing. But I'm not dividing, am I? I'm multiplying by a fraction. Math. Don't mess with me. So, question. Does row 1 change? That's 1, 3, 2, 25. What's half of 0? What's half of, or negative half of negative 2? And then what's negative half of 0? And what is a negative half of 6? Beautiful. Now, does my last row change? Nope. 0, negative 8, negative 4, negative 44.
So then you multiply the last one by negative 1/4.
So now, I want to get rid of this negative 8.
Negative 1/8.
So Isaac, how can I get this to be a 0? I can add a positive 8 to it, right? So that means I'm probably going to have to do one of those plus ones, aren't I? Add something to row 3.
Add row 2. But
Yeah.
multiply it by 8.
I'm going to take row 2, multiply it by 8, and then add those values to row 3. That's horrible. Waterfalls. Stop and look at that for a second. Why didn't I use the first row? There'd be too weird, right? I have to use weird fractions and stuff, and then to add them. And if I added them to here, what would happen to my 0? It would turn into something else, wouldn't it? So I'm going to use that second one. So here are the values. What's 8 times 0? 0. What's 8 times 1? 8 times 0. And 8 times 3? 24. So here I go. Did my first row change? Nope. So 1, 3, 2. This is getting smaller and smaller, isn't it? I can probably fix that. 25. Did my second row change? 0, 1, 0, 3. Did my last row change? So now I've got 0, 0, negative 4, negative 20. Cool beans. Multiply by negative 1, 4. So I'm going to take row 3, multiply by negative 1, 4. Here we go. So, what the? Did my first row change?
Nope.
1, 3, 2, 25. Did my second row change? 0, 1, 0, 3. Did my last row change? Yeah, that was 0, 0, 1. Okay. Cool beans. So, let me tell you what this means as far as systems are concerned. That means that x plus 3y plus 2z equals 25. In this middle one, y equals 3, and the last one. So now I just can take those, plug them into y and z, and get my value for x. So it's a little waterfalls. So it looks like it's a lot, but it was a lot of fast work, right? Because all I'm really doing is multiplying, adding, or adding. It took 20 minutes because I was explaining everything. Can you guys see that okay? So Maddie, the answer was no. I don't think that was the matrix that they had below.
Yeah, I was looking at that while you're going through. I was like, no, it's not 19.
That's not the one. And on top of that, it's fast. It really is. Like once you can't think like that. Any computer programmers? Any future computer programmers? Any future computer programmers in here? Okay, well it's that face. I would say welcome to your future, because computer programming is all about organizing arrays and matrices and being able to modify any future game developers. Future game developers? No? I should have just said computer science.
Hexadecimal, that's this man's specialty.
Really? Oh, you liked it. I already showed you guys hexadecimal. Did you go back and show it to your parents? Did they like that? It's pretty interesting, huh?
My dad works
Your dad works for what?
for Intel.
So he already knew about it? Like, I gotta do your job now. That's dope. So were you guys geeking out together then after that?
A little bit.
A little bit? That's funny. You should see a binary problem. Binaries are, you would think that like, oh, they're so easy because it's only 2 numbers. But to add like actual numbers from our world in base 2 is just a string, like it's just long. Because there's not enough to carry. It's 0 or it's 1, and if it's 1, you've hit binary pretty much. Or sorry, if it's 2, you've hit the binary limit, so you got to carry and then go keep carrying. So you just get a string of 1s and 0s, or 0s and 1s, or 0s and 0s, whatever it is.
It's like 25 would be a bunch of 0s and 1s.
Oh, 20 is massive. It's huge, yeah. Here, let me. Hold on, people are still writing there. So like, let's see here. So here's your numbers in binary. You're starting with, so 0 is 0, 1 is 1, 2 is 3 is this, 4 is now 1 0 0, and then 5 is now 1 0 1, 6 is now 1 1 0, 7 is now 1 1 1, and then all you're doing is adding. So can you imagine getting to 20? We only got 7, right? So once you get to 20, it's like well, if you wanted to do 8, that's 4 plus 4, right? So that would be 4 plus 4, which is technically 100 plus 100. So that's 0, 0. That's a 2. So that's 0, carry 1. So there's 8. Yeah. Now if you wanted to do like, let's do one more. 9. So 9 would be 1 0 0 1. Because now with those, you can do all the other by 5.
1 0 1 1.
1 0 1 0. So yeah, so if you wanted to do here, so 1 0 0 1 plus 1, which is that, that's 2, which means 0 carry 1, 1 0 1. So that's 10. If you want to do what, 15? 15, that would be 6 plus 9. So you got 1 1 1 1. So there it is. That's 15. 10 plus 10? Well, here, this is 10, right? So 10 plus 10 would be 0. That's 0 carry 1, and that would be 0 carry 1. So that's 20 right here.
Just look. 1 1 1 1. That's 50.
Because once you hit 2, you have to carry. Because now you get your base. That's why there's only 1 0. That's for you. Are we good with this slide? No, not yet. Waterfalls. Everybody get up for a second. Get up off your chair. Everybody get up, stretch for a little bit. You're welcome to dance, stretch it out. About 30 seconds, go.
I'll be Kesha.
Have a seat. Waterfalls. So here's the deal. Somewhere around midpoint, you guys have to remind me to do this mind break. I'll give you guys about 30 seconds to a minute. Get up, stretch, whatever you got to do to get back in the game. Check your phones. I know y'all trying to check that newest TikTok. Did I got there as a joke because I had in my first hour, there's 2 girls that are always doing like their little dances and stuff. So like, I'm gonna check this out, see what it's about. I don't know what that is, anyways. And then I'm like, now I'm just like hooked. I'm like, it's like the vines. Remember the little vines are like, oh man. So
Say a funny one.
no, not right now. Right now it's time to get back to work. So all I'm saying is, please remind me we need a mind break because it's a lot sometimes, isn't it? Okay. So I just want to remind everyone what we've been working on. Writing the augmented matrix. We're good. Just matrix with some solutions, right? Perform matrix operations. How many operations are there? 3. Name one of them.
Oh,
Think about what they are. Think about what they are. I'm gonna have someone. I'm gonna have you guys.
can we make them rhyme? How can we make them rhyme?
Can we make a song out of it?
Yeah.
So let's try this again. I'm gonna be biased. I don't have my dojo up. So let's go with Malia. Give me one of the operators.
Row swap.
Row swap. Thank you. Malia, give me another one.
Oh, that was the one that you multiplied. Like, that is the like coded.
Kager, go ahead. So we already have row swap, and we designate row swap with using arrows back and forth, right? So this means swap row 1 with row 2. What's another one of my operators? Go ahead, Kicker. You multiply a row, so we'll multiply Ri by some constant, and we'll add that to row J. So there's the other one, and there's one more. Go for it. Just the normal multiply. So you can take some row multiplied by a constant. Okay. So there's your 3 operators. Row swap, multiply a row, and add it to a different row. Now, what we did, go ahead, bud.
Do the last
Why falls?
Whenever you do the last way to do it, like you multiply that constant, you said,
It's just that row.
you just need it.
You just, yeah, whatever row that is, you're just changing all the values by that amount.
You just pick it out.
I'm sorry, there's just like so much talking right now. That's unprofessional. So, your question one more time, please?
You just pick an amount to multiply it out.
Yeah, and remember, you can do that to whatever equation you want as long as you do to the whole thing. So all we're doing is making an equivalent one that can be bigger or smaller, however we want. Okay? Now, what we just did with that, what was it, row echelon? That's called the Gaussian elimination method. That's the Gaussian elimination method. We just did row echelon. Now, if we went further and we did what's called reduced row echelon, that becomes Gauss-Jordan. Because Jordan came back and said, hey, I can make this better. Okay? So let me show you what reduced row echelon looks like. No, I'm going to show you by hand. In reduced row echelon, we're getting a matrix where... Oh, I don't have them. You're getting a matrix where all the values below are 0 and above are 0 as well. So what you have, in essence, is something called an identity matrix. 1, 0, 0, 0, 1, 0, 0, 0, 1, and then you'd have solutions.
Oh, and that's what just the answer.
So this would be, right, so each one would just be the answer. An x is equal to 2, a y is equal to 3, a z would be equal to 1. So this is the Gauss-Jordan.
Get like the actual answer.
Say that one more time.
So it's like more work for you to get the answer, not have
Yeah, it's a little bit more work, but you go straight to the solutions. And it's really not a lot more because now you're only, well, technically, yeah, you're doing the same.
You can just use the
You're doing the other 3. Okay? So, if we went to here, we would be trying to take this 3 and make it a 0. How can we do that?
Row multiplied by 2
By -3.
Right. So all that operation. Now, I'm not going to push you through that. You got to make sure you understand how those numbers are coming about and what's happening with them. On your calculators, let's clear this up. If you go over to the matrix menu, all those options are available for you. I'm going to go over to math. And as I work my way down this list of values, notice here is C. There's your row swap, so it'll row swap for you. Here's your row. You can add a row to the other row. Here is multiply a row, and I think they even have the other one. Yeah. So this is multiply a row and add it to the other one. Is this any different from this one here?
Yeah.
They're not really different, except this one just got multiplied by 1. So this one is not even really a row operator. Okay. This one is multiplied by 1 and then added to another column. So if you want to do that, that's okay. What's up, bud?
If you put your like equations into the edit,
Into a matrix?
yeah, you can just find the values there, right?
Say that one more time.
If you just put the matrix C into the calculator, you can just find the values there, right?
In here?
No. Go
Oh, but yeah, we have to make the yeah. Oh yeah, definitely. If you go over to matrix, you go edit, and you put those in there. We were doing that when we did systems, right? Let me show you what these are the equivalents for. Let's go over to math. So this is the Gauss method, which is your REF, which is, if you put it in the calculator, I'm not wasting my time. I'm going to go with this method, which is the Gauss-Jordan. Cool? And of course, C, D, E, and F are the methods for doing REF and RREF. Row echelon form, reduced row echelon form. Okay?
with the calculator, what's the difference?
If I'm going to put in the calculator, I'm not messing with the last ones. Now, I had to do it with brief calc. When I took brief calc at the college, we had to use the row swaps, and we had to write down like what methods we were using. We actually had to write down the buttons and the script the way I was showing you, row swapping and then multiplying the row and stuff. I don't know if you'll encounter that. If I'm not going to encounter that, then I'm not going to waste my time doing the last 4. I'm going to go straight to RREF. If I'm just trying to solve a system.
There's an augmented, like, number 7 on the list says augment. What's that do? Is that like does that put in the augmented matrix that we were like trying to do?
No, because it can't be. Because remember, the augmented matrix simply adds the solutions. If you only put the matrix part in it, how will it know what the solutions are? Right?
It's kind of there.
Right. So, if you really care, I thought I had some calculator handbooks back there. Oh, yeah, there should be down the shelf, right down the black shelf. If you care enough, go take a look and see what augment does. Okay? But we'll talk about some of the other things later on. How are we on time? You guys good?
It is. We have 5 minutes.
There it is. So, let me clear my throat. Waterfalls. So just as a reminder, write an augmented matrix, thumbs up, thumbs down. Perform matrix operations. I know you might still be sideways, but any thumbs down. Okay, make sure that if there's any thumbs down, you let me know in the but that's all, folks, in the exit ticket. I couldn't say the word. I couldn't even think of it, so I'm like,
Wait, can you bring that back? No. I wanted to take a picture of the rules. Bro. It's too many of us. I wanted the rules.
give me a second. Whoa, you state. There they are.
They are in fact.
Someone said that in the last time.
Wait, Mr. Williams, I'm on your website. Where's your exit to?
Thank you. Hey, why don't you put that in the feedback? Put it in the feedback.